Lesson I gave to you guys was to figure out what this height was, because it's launched at 0 degrees and you'd like to figure out how long it takes for it to reach the ground. Many of you came up and took a measurement, and from what I saw of you, you walked away with a measurement of 1.06 to 1.07. If it were me, I would have measured from the bottom of the circle, because it's the bottom of the ball that's going to hit the floor, not the middle of the ball. But that really is not going to make that big a difference. So let's use the middle of this. Let's say that the delta y is 1.065. Let's also say the initial y velocity will be, and I'm going to put this the long way, v naught sine 0 degrees. I don't know what v naught is, but I do know that I set the angle for 0 degrees, which means that should make it 0 meters per second. And the acceleration of gravity, I'd use 9.8 meters per second squared if I were doing this. Now, you'd like to figure out how long it takes to reach the ground. You need that piece of information first. So with what's here, I would probably recommend you use delta y equals 1/2 a t squared plus vy naught times t. But, and I stress, this is downwards and this is downwards, so let's make upwards positive and to the right positive. This will make it negative 1.065 equals 1/2 times negative 9.8 t squared plus 0. So then you could find out how long it took to reach the ground. And how long does it take to reach the ground? Almost everybody has this. 0.4 what?
6.
All right. I would keep decimal places here if I were you in your calculator. So, while it takes 0.466 seconds to reach the ground, we know that the projectile is actually traveling sideways at the same time. So we can measure where it strikes the ground using this information. Many of you did. We found it was about 2.19 meters to 2.2 meters. Does that seem like what you measured? A centimeter off here or there does begin to add up. But I think we can all agree that that's pretty good. This represents the horizontal motion. So if this was the vertical, the horizontal would have been r, vx, and t. The time we know, 0.466 seconds. The range we measured, 2.195. I just put it right in the middle. So if I want Vx, now just a reminder, Vx is actually V naught cosine 0 degrees. But 0 degrees gives us a cosine of 1. So right now we are measuring both Vx and V naught when we do this division here. And I'm pretty sure you're going to get 4 point something. 4 point what? Now I would keep decimal places here. Meters per second. This is how fast my launcher will launch a projectile. And it will do so at any angle that you set it. So we're going to set it for what angle? 30 degrees. So if you don't mind, shooting upwards 4.7 sine 30 degrees. But it's not going to change the height from the from the launcher to the floor. That's still going to be the same height, minus 1.065. Gravity's not going to change, 9.8 meters per second squared. So I need that to figure out T. There are a lot of different times in the room, but it's not going to be much more than it was before. But it certainly will be more, because we're shooting it upwards into the air. So I'm thinking negative 1.065 equals 1/2 times negative 9.8 t squared plus 4.7 times the sine of 30 times t. You've got to make your quadratic formula work for you here. And we want the positive value of time. I suspect it's about 3/4 of a second, but I don't know for sure. How many of you got 0.76? It's not very many of you. Now, just so you guys know, you can't get this. And if you can't get this, you're done. You can't do this problem. If you need help, please seek help. I'm happy to help you. But now that we know the time is 0.764, we got to take and find 4.7 times the cosine of 30 times 0.764, which is going to be about 3.1? I get about 3.1 with some change. Questions? Well, here's the important thing. You need to know where this is. And this is not 3 meters and 1 centimeter. This is 3 meters and 10 centimeters. That's a big difference when you put it down there on the ground. But let's do it. Actually is one we talked about. We'd call this a type 2 problem. I'd call it type 2 because the person jumping lands at the same height they left at. So when I consider this problem, vertical and horizontal, delta y equals 0. That's critical or you couldn't do this question. Well, you could, but it would have been really much harder. Moving on from there, the acceleration is still going to be 9.8 meters per second squared. The initial y velocity will be this unknown times the sine of 10 degrees. And that's really it. We want to figure out the time. We don't have enough because we don't know what V0 is. Let's look at the horizontal. The horizontal is 69.5. We know the horizontal velocity is V0 cosine 10 degrees. We'd like to find the time. But as I'm sure you're guessing now, you can't find the time here either. That's tough. This is why you took all those years of algebra, though. When I look at this, I see a relationship here that has V0 in it. Raise your hand if you know where that comes from, what I just wrote on the board. That's not enough of you. So the rest of you who aren't putting your hand up, range equals Vx times t, or 69.5 equals V0 cosine 10 times t. So when I solve this for the time, I get 69.5 divided by V0 times the cosine of 10. By the way, what is the cosine of 10? You have access to fancy adding machines. 0.9, give me like 4 of those. 0.98 times V naught. All right. I'm going to set that aside, but not for very long, because I could put all of this in for T here. Think about it. Delta Y equals 1/2 a T squared plus Vy initial times T. As I keep saying, you're trying to solve for time on one side and plug it into the other. Why didn't you? 0 equals 1/2 times negative 9.8 times 69.5 over 0.9848 V naught squared plus V naught sine 10. Ooh, what is V naught times the sine of 10? I don't want sine of 10. Just tell me sine of 10. 0.1736 times 69.5 over 0.9848 times V naught. Wow, that's a mess. It is a mess, but as messes go, there's only one unknown in that big mess. One unknown. I could figure it out because I learned algebra. On the other hand, too, I could see that this one and this one would cancel out. One's in the numerator, one's in the denominator. Do you see that? So you're going to let this stand between you and the answer? I wouldn't. Make it happen. That's what I expect of you. I expect you to work at your level. This is the level I expect. And I know you can do it. You just never really had to before. Part B. All right, number 5, part B. Wow, 26 people have submitted it already. Good job. All right. So you shoot the arrow straight up, and you're able to figure out what the velocity is from that. I mean, it says it goes 31 meters. It reaches the top of a 31 meter tall building, and it started 1.45 meters from the ground. So that suggests that if you shot it from here, and it waited all the way to the 31 meter mark, what was delta Y when you shot it straight upwards? Good job, 29 point what? There it is, 29.55. I don't know what the initial Y velocity was that did that, but I do know that the final velocity had to be 0 if it just reached the top of the building with an acceleration of negative 9.8 meters per second squared, assuming upwards is positive. I think I can figure out what this velocity was. So, in order to do so, I'm going to use V final squared minus Vy initial squared equals 2 times negative 9.8 times 29.55. And this number is 0. So that Vy initial will be the square root, whatever all this garbage is, 2 times 9.8 times 29.55. I canceled the 2 negative signs, by the way, this one and this one. So, I don't know, the square root is 600. What is it? 24.06 meters per second. So when part B gets here, it says, where do you need to put a target that is 1.45 meters above the ground in order to hit it if you aim 30 degrees above the horizontal while pulling the bow the same way? So it sounds like I'm putting a target over here someplace. That's the same height as where I started, but I am shooting at an angle of 30 degrees and a speed of 24.06 meters per second. It feels to me like this is supposed to be a type 2 problem, or they're trying to make it a type 2 problem because they're making my target the same height as where I launched from. They're giving me an angle of 30 degrees and a launch velocity of 24.06. So I'm going to create a projectile problem from there where delta y is going to be 0 because it's going to land the same height as it's launched. The initial y velocity is going to be 24.06 sine 30 degrees. I don't know what Vy is and don't care. The acceleration will be gravity, 9.8 meters per second squared. I'd like the time that it's in the air. Vx is going to be 24.06 cosine 30 degrees. I can get the time here and use it there. Does that answer your part B?
Thank you.
You're welcome.